So, a very good evening to everyone present in day 3 of this program. Today, we are going to conduct the session 5. So, at first, a very good evening to Engineer Soumya Ranjan Naik. Uh, Before that, I welcome you, sir, to our program. Mr. Soumya Ranjan Naik presently is working in Ultratech Building Product Division and positioning in a post area head technical customer solution of East Zone. He is a civil engineer with over 12 years of well-rounded experience in the construction and building product industry, including cement, putty, waterproofing, tile adhesives, and related segments, skilled in providing technical solutions, customer support, and marketing initiatives to drive product performance and brand visibility. Experienced in brand building, conducting product trials and development, and delivering technical training to internal teams and external stakeholders. He has already saw in companies like L&T Construction, Dalmia Cement, and presently he is working in Ultratech Cement since 2021. He is graduated from Indira Gandhi Institute of Technology, which is an autonomous institute of Government of Odisha, and executive program in global business management from Indian Institute of Management, Calcutta, IIMC. So, I now request our expert, the speaker, Mr. Soumya Ranjan Naik, and we have a very good session today because he is going to deliver in a topic which is almost a modern method, and the topic is new age construction solutions, waterproofing, durable structures, and modern tile and stone fixing as per Indian standards. So, again, I welcome you, sir, to this session, and I request you to start your session. Thank you, sir.
Thank you so much, Dr. Pankaj, for giving a very warm introduction. And I am very fortunate to having all our faculties. Rather, I say all these participants are the future shapers of our engineers. And I can see one of my professor, Bhagirathi Tripathi sir, also is in the session. Uh, and also many faces I know, and really looking forward to have a good session. Although I am covering a vast area, I will try my level best to make you understand. Okay, so let's begin the session. So I am sharing my screen now, Dr. Pankaj. Yeah,
Yes.
yeah. So just let me know if my screen is visible. So yeah, yeah. Just confirm me that my screen is visible.
Yes, yes, sir. Your screen is visible.
Yeah. So we will cover the waterproofing for durable structures and modern tile and stone fixing solutions. So before moving forward, I will try to elaborate you regarding this tile and stone fixing, how it has been used and being fixed in older days, and how its evolution to our modern age. and what our IS standards is suggesting, and how this present construction industry is looking forward the solution from the engineers are delivering the solutions of tiles and stone fixing. Okay, so if you see in previous trends, this terrazzo and China mosaic tiles used to fix. If you see in in every one of our older homes or in previous construction practices, they used to fix terrazzo and China mosaic tiles made with cement, clay, and stone chips. And then small tiles application started, where we use these tiles in only bathrooms and kitchens. Then we are using then we used to use natural stones like big stones, marbles, and all these things in only floor applications. Then in present trend, more of this construction, whether it is a project, whether it be individual house builder, they are looking for a larger tiles or composite tiles. Like composite tiles, when I say composite tiles, it means fiber, plastic, stone, clay. These things are mixed to give you a stone-like look with a cheaper price. So nowadays you barely see a home without tiles. Every second home constructed is now being used with tiles. So this is very important. We should know what our IS standard suggests to fixing these tiles and stones. So before that, we should know what are the types of tiles are available in the market. So there are ceramic tiles which are very absorbent in nature for waters. Then Proclaim and Vertified tiles, they are non-absorbent for water, like it's almost absorb below 5% of water. Then glass mosaics, you see, these are the small glass mosaics, and they come with a traditional fixer to fix them. Let's take a laser. Yeah. So present these type of tiles are available in the market. Obviously, if, for better understanding, I am giving you a view with glass. So glass are zero absorbent for water. Then if you compared with ceramic tiles are morely made of clay. So they absorb water more than 10%. But in case of vertified tiles, they will absorb water less than 3%, almost non-absorbent. Okay. So why I am elaborating this? Because we need a different kind of material to stick these tiles to the substrates. If a material is non-absorbent in nature, so we require that kind of adhesive which will be which are capable of sticking this non-absorbent material to your plaster or in any substrate you want to fix the tile or stone. Okay. And if you see like bricks, and all these things, they are very absorbent in nature. So when we use cement mortar to fix these things, so these are very absorbent in nature. But when we come to a non-absorbent material, like you say a Sonmica board, a plywood, they cannot be fixed with cement because they are very non-absorbent. Similarly, these tiles are also very non-absorbent, like vitrified tiles and porcelain tiles. Then obviously there are different type of stones available in the market. Uh, Normal quarry stones, and there are composite stones also. We use different type of polymer or plastics or modifiers to mix with stone dust to give a composite kind of tile and stone. So nowadays, the construction industry demands the fixing of tiles and stones in every kind of surface. Previously, as you saw, and as we are experienced, as you have experienced previously, what happened? People are used to fix the tiles and stones on only on the cement software, like plasters, concrete, in these kind of things. And if we see now, the construction in demand that they want to fix these tiles and stones on a plyboard, on a metal board, on a aluminium board, on a wooden surface. So we need different kind of adhesives to fix this. We cannot say that we will fix all these things with cement, because this is not possible. So now you see the latest trend of tile fixing is like that only. People are fixing tiles in everywhere, in exterior, in interior, any dimension. There are tiles are like 10 feet by 6 feet. This kind of big tiles are being used in construction nowadays. So for that we need a better solution and a modern approach. Saying that modern approach and better solution, also we have to look into the cost effectiveness, because anything without cost effectiveness and durability is not a modern a solution for now. If you see, हमने चंद्रयान भेजा, हमने मंगलयान भेजा, तो हमने we place it very lower cost in comparison to Americans and Russians and Chinese. So what we see, we need a modern approach solution with a durable approach, which will eventually be a cost economical matter for our customer. Yeah. So why not we use cement in tile fixing? Because you see, cement requires curing. Okay. So when we do a plaster, or we do a concrete work, after that immediately we have to do 7 days or 14 days curing as per the requirement of cement or concrete. If you don't do that, what will happen? You will not get the desired strength, and in case of cement, we will get a shrinkage crack and all these things. So when we fix tile with cement, we will not able to cure it. So eventually it will lead to shrinkage cracks and other different things like hollowness and the desired strength and adhesion we will not get. So that thing, it will lead to this kind of challenges. Like when you use only cement for tile fixing, you will not able to cure it, because you will apply tile on the cement or stone on the cement. So due to lower strength and shrinkage and all these things, bulking happens, and due to shrinkage and cracks in the cement layer, the crack eventually develop in the tiles, and due to gap and hollowness in the binding material like tile adhesives, so our dirt enter into the gaps and so into the white marbles and tiles. Then obviously if the cement will if the cement will not achieve its desired strength, our tile and marbles will debond, and we don't have control over shrinkage and all these things. If you don't cure it, then this kind of lapping issue so happens due to improper strength and shrinkage. Hollow sounds and happening, and there from this point tiles and stones will crack, and due to gaps water enters and efflusions happens. And obviously we know there are cement is not a thixotropic material, So when we apply tiles, in going forward, I will show what kind of strength, uh, what type of loads are going to come over a tile, and what the behavior of tile adhesives or adhesives have to experience. So in vertical walls, obviously cement is not a thick sort of material. In vertical walls, we will have more western kind of thing. Yeah. So for durable tile and stone fixing solutions, now we suggest to, instead of cement, our engineers must use tile adhesives for durable and more safer construction. Also, needless to mention that it will enhance the aesthetic of the building or construction. And when I say tile adhesive, we will go into details. What happens? Tile adhesion will give a cohesion between the substrate and the tile. Tile adhesive is a material which has a self curing technology. We know it's required no curing. Also, it has dual shrinkage property. What happens? It will adjust its shrinkage at the time of hardening. So that means at the time of laying the tile adhesive fresh, and when the tile adhesive gets hardened, the area will not shrink. The tile adhesive at the time of application, the area tile adhesive covers, it will remain the same. Unlike cement or concrete, what happens? Cement or concrete somehow shrinks after 24 hours or after 12 hours. But tile adhesive, it will not shrink. At the time of application, the area it will cover until the end, it will cover the same area, it will not shrink. So these are high-tech binding particles, say by particles, self-curing technology, and that leads to no hollowness, of course, because it has a good flowability and thixotropic in nature. In thixotropic nature, what I want to explain, yeah. If I say two more thixotropic material, you can relate toothpaste. Toothpaste is a thixotropic material. Every morning we use toothpaste. If if you open your toothpaste and put the tube of your toothpaste towards the ground, the toothpaste will not flow automatically. When you apply stress, the toothpaste will flow. Yes. So thixotropic materials behave in anti-gravity manner. When you apply stress, it will start flowing. So similarly, tile adhesives are like that. When you apply tile adhesive on the wall, it will not fall down. So that will lead to less wastage and good grips on the tiles. So that's why if you see, maximum of the government organizations and all the I have shown some of the names. Private organizations are made mandate that all the tiles and stones should be fixed with the tile adhesives, and the gaps should be filled with tile grout. So if you see all the tender copies and make list of recent days of all these uh, government bodies or private bodies, I have listed some of them. Almost all the government and private bodies have make a mandate that the contractor must use tile adhesive to fix the tiles. Now, saying so, let's move towards IA standard of tile adhesive. Yeah. So IS 15477, which is recently last amended in 2019, is for the IS standard for our tile and tile adhesives for tile and stone fixing. It clearly mentions what are the types of tile adhesive is to be used and what are their behaviors. You can very well have a look towards it, and there are many tests also mentioned in the tile adhesive. Yeah. So let's have a brief look towards this IS code. What it says in the IS code briefly divide the tile adhesives into 5 types of tile adhesives, looking into the different types of tiles and substrates. Okay, the first type of tile adhesives are meant to be used on clay and ceramic tiles. If you remember, previously I told that clay and ceramic tiles are the tiles who are water absorbent in nature. They can absorb more than 10% of water, and these type 1 tile adhesives are meant for ceramic and clay tiles only, to fix in only interior walls and floors, and the size of tiles must be less than 300 mm. 300 mm. So small clay and ceramic tiles, we are supposed to use type 1 tile adhesives. Saying so, if you like in cement, the IS code is mentioned in every bag of cement. In tile adhesive also, in each bag of tile adhesive, it's mentioned that it confirms this IS code and also what type 1 or type 2. Okay, so in type 2 tile adhesive, it says it 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 will be applicable for greater than 300 mm tiles, and it's for vitrified tiles, glass mosaics, stones, and large dimensions in interior floors and walls and exterior floors. Mm, I think yeah, and exterior floors. So so this is the exterior floors. I will give the examples like balconies and chajjas. These are exterior. Sorry, like balconies are called the exterior floors. Like verandas also, where the roof there are covered floors. Okay, we can use type 2. For type 3, there is type 3 are the same kind of area we can use, but it allows for external walls and internal walls both. Okay, for all ceramic, clay, vitrified glass mosaic, Portland tiles, and all natural stones. But its sides, it says that for greater than 300 mm, you can use this, but it should be less than 600 mm for type 3. And type 3 is the kind of tile adhesive which in regular construction, for all type in regular construction, like institutional individual house builders, like many of the home construction, these are commonly used. Type 3 is a commonly used tile adhesive because it's a all purpose tile adhesive. You can paste tiles, stones in exterior and interior also. I think there is a green line drawn on the screen. I don't know how to erase it. If, someone can help with it. Yeah. Dr. Pankaj, am I audible? Yeah, can anyone confirm that I am audible or
Yes,
not?
sir. Yes, sir. You are audible, sir.
I think someone has drawn by mistake this a green line. How can I erase it? Yeah, yeah. I got it. Now I can erase it. Yeah, yeah. Got it. Got it.
Okay, okay, sir. Now it is okay.
Now, by mistake, I think someone has drawn a green line. Okay. Yeah. So, so type 1, 2, 3 are basically commonly used in regular household purposes. Okay. And type 4 are generally used for big projects where uh, there is a requirement of big tiles and stones, uh, where the properties like deformability comes. You have to fix a tiles in a area where vibrations happens, in a parking area, uh, big style of big stones and tiles greater than you say greater than 5 feet or 6 feet. So in type 4, there are two. In type 4 also you define there are two types of tile adhesive available in type 4. One is S1, another is S2 property. What is S1 and S2? I will explain in next slide. S1 and S2 is explained as deformability. Deformability means when the substrate, suppose a tile adhesive applied on a parking area. Okay, when load comes on the parking, the floor vibrates. So if the tile adhesive has that much deformability capacity to deform, what happens? The tile adhesive will leave the substrate or leave the tile. Eventually, the tile will debond from the surface. If I can explain, let me see. Let's try to share this. Yeah. Yes. Now, if you can see my screen, sorry.
It is visible, sir.
I just want to show something. Yeah. Yeah. In this image, if you see, yeah, this is what I mean by deformable adhesive. When you, if the tile adhesive is not, this is a thin layer made with tile adhesives, and when you apply load, it will break. If it will break, it will leave its hold from the substrate or tiles. But it's a deformable tile adhesive. It has a elastic property like this. It will bend and come into its original position. Okay. So let's see what our IS code says about these deformable tile adhesives. Okay. So there are S1 and S2. I will explain what is S1 and S2. S1 says that the tile adhesive can deform from 2.5 mm to 5 mm. Otherwise, type 1 and type 2 and type 3, these three tile adhesives has a deformability below 1 to, between 1 to 2.5 mm. They can differ. But type 4 must have a deformability capacity from 2.5 mm to 5 mm, which is S1. For S for type 4 tile adhesive and having S2 deformability, must have to show a deformability from 2 greater than 5 mm. Then type 5. Type 5 from till type 4, all these adhesives are meant for cement and dry substrate. Okay, but type 4 is meant for wooden, metal, plyboard, all kind of aluminum, stainless steel, mild steel, uh, like in lift areas. In some of the construction, we use steel staircase. If you want to fix a tiles or stone in a steel staircase or a metal staircase, we have to use type 5 type tile adhesive. Till type 1 to type 4, all are cementitious tile adhesives. Okay, but type 5 is a resin based tile adhesive. It's epoxy based or polyurethane based tile adhesives. These are reactive tile adhesives. You have to mix two materials, the two kind of components. They will mix and react, and they will act as adhesives, like epoxy and polyurethane. Type 1, Type 2, Type 3 are cementitious tile adhesives. They are made with cement and polymers. Type 5 are polyurethane and epoxy based tile adhesives. They used polyurethane and epoxy to bind tile with different software like gypsum board, plywood, wood, metal, steel, and all these things, copper. Any metal you name it, they have the capability to hold the tiles and stones to the surface. Saying so, type 5 has a higher deformability capability. So it can be used in high vibration areas, in all industrial areas where high vibration are used to happen. You have to use type 5 of tile adhesive. So IS code specifies that in for different softwares, different size and different requirement, we have to choose these kind of types. We have to choose what type of tile adhesives we have to use. When you place a order or you demand a tile adhesive from the market or any of the company, you just have to say, I want a type 4, type 5. They are already written on the bag that it's a type 5 adhesive, type 4 adhesive, type 1. For general household, type 3 is enough. Then for projects and big other areas, type 4 and type 5s are used. Okay. So I think for IS code perspectives, we understood these are the 5 types of tile adhesives available in the market for different applications to fix tiles in the different substrate. Hope we understood that this is a very important slide, and obviously I will share this document with you. But saying so, you have to understand this what I am saying, and I will take questions on this if time permits, and I will share this IS code in the IS code with all of you, and I will share to Synergy, and they may circulate this. Okay, and there are some tests also mentioned in the IS code, which maximum of the test require no instrument. We can simply do with tiles, tile and tile adhesives. So I am not going into details of testing. So I rather emphasize that we should know what what are the types of tile adhesives as per IS code and what are the different applications. Because we must know that, because every construction or every building is now using tiles and stones, and it's important that we suggest them proper building material for a better and durable construction. Yes. Also, in some of the big projects, they follow European norms, EN code and IS code. But now IS code is also ISO is also there, but maximum of the construction is now moved to IS 15477. But these are the synonyms summarized by here. C1 is normal cementitious, C2 is improved cementitious, and there are some properties must be there in tile adhesives, like slip resistance. Slip resistance means when you apply tiles, it will not slip. When you apply a tile in the vertical wall, it will not slip. If it will slip, it will be it will below 0.5 mm. That's the typical nature of a thixotropic material. If you see here, yeah, now let's me take the laser pointer. Yeah, this is the slip resistance. Means when you apply a tile on a wall, immediately after application, the tile must not slip more than 0.5 mm. It's very difficult to measure it from naked eye, but this is the criteria a tile adhesive has to maintain. That's why we are saying we have to shift from cement to tile adhesives, because these things are meant for tiles. Otherwise, what will happen? You are going to you keep on fixing the tiles, and the tiles will slip one by one, and you will never get a proper lines in fixing of tiles. And tensile adhesion strength, I will show you what are the IS requirement for type 1, type 2, and type 3. Let me explain what is open time. Open time means after uh, uh, after mixing water, it's like workable time. Open time is like workable time. Okay, it's very much similar to workable time. After mixing water in the tile adhesive, uh, how much time it will allow you to use it or fix it a tile with the substrate. Okay, so so deformity, as I told you previously, as I show you the picture also. S1 means in tile bags also they mentioned this is S1. S1 means it has a deformity. It can deform. It can bend up to 2.5 mm to 5 mm. S2 means high deformity. It can bend more than 5 mm. Extended open time means general open time is like 30 minutes. Okay, extended open time means it will give a open time of more than 30 minutes. Okay, and these are the strength mentioned 0.5 Newton per mm square. These are the tensile strengths, tensile adhesion strengths. So for now, just ignore the strengths. I will tell you about the strengths again. Strengths again. For now, you must understand that open time and extended open time. While extended open times require, if say you are fixing a large tile on uh, a 15th floor apartment or 15th floor building, you are fixing that tile on a 20-30 feet height. So obviously in 30 minutes it will be very difficult to mix it and fix the tile in proper manner. That's why extended open time is given in higher tile adhesives like type 4 and type 5 to give you more workable time. Okay, these are the improved things, modern technology given in the material to make our construction uh, happen with safety and achieve its proper strength with proper aesthetic as desired by our customer. So, the selection criteria of adhesives, how we select adhesives, firstly I told this, I explained you all these things. What type of tiles you are choosing and what size of tiles you are choosing. What are the software like observant and non-observant? So if they are observant, you can go for type 1 like clay tiles, and other than clay tiles, ceramic tiles, these all are non-observant. Use of area, if there is mechanical stress, thermal stress, exposure condition, traffic area, and what are the height of institutional publicity, public safety. These things must be taken into consideration while we are choosing a tile adhesive, whether we will go for type 1, type 2, type 3, type 4. Okay. Generally, in application of tiles, what are the different type of loads that tile adhesives have to experience? If you see in the picture, tiles are fixed in a upward direction opposite to the gravity on the roof. So here, tile adhesive have to hold the tiles against the gravity. So here the tile adhesive has to bear the load of tiles. Okay, in this kind of application, the tile adhesive is experiencing a tensile load directly in the direction of gravity. Okay, so for this, we may prefer type 4 or type 5 of tile adhesives. Okay, looking into the size. Then another type of flow. This is very common, as I say, in lift area, in traffic area, or in suppose you are fixing a tile where a machine or like digital generator is there or a machine is there. So there is experience of vibration and all these things. So here here is the substrate and this one is the tile, and in between tile adhesive is there. So tile adhesive has to that much flexible to accommodate this kind of vibration where the deformability comes into place, the elastic nature of tile adhesive. So in there also we have to go for type 4 or type 5 of tile adhesives. Again, if you go another type of tile adhesive, these are very common. But we are fixing big tiles in vertical walls. So what happens? The tile adhesives have to hold the tiles, and the skidding, the slip resistance is come into the picture here. Okay. So these are the three ways where the tile adhesive has to hold the tiles from these are the three type of loads where the tile adhesive has to uh, uh, work to hold the tiles. To bear these loads, tile adhesives are made likewise, and we have to choose accordingly from these IS codes. There are different type of tests also there. I will also show you a video how we do these tensile adhesion tests. Okay. Yeah. Before that, what I told, what our BIS standard specifies that what in what are the type of tile adhesives I mentioned you earlier. Now I am showing you what BIS certifies that what is the minimum tensile adhesion and shear adhesion will be there. Okay. So for type 1, uh, in dry condition, the 0.5 Newton per meter will be the tensile adhesion. and for shear it will be 1. For type 2 dry and wet condition it will be 1, and shear it will be 1. And you can see also here heat aging condition and wet condition. Okay. So from these things we for as per our requirements we can choose the type of tiles recommended by the BIS code. Okay, I will show how we do the testing for this adhesion. And generally, the open time testing are done by only fixing the tiles, and after 30 minutes, we will show we will see how the tile adhesive is in workable condition or not. Okay. So as I earlier mentioned in BIS code also, these are the direct words from our BIS code I am showing here. Okay, in BIS code mentioned deformability means S1 means 2.5 mm to 5 mm, deformability to S2 is greater than 5 mm. Slip resistance, as I mentioned, when we apply a tile, immediately it will, after application also, after immediate application, it must not slip more than 0.5 mm. Okay, these things are mentioned in back, or also you can ask for a technical data sheet from the company we are purchasing tiles. Yeah. So I am showing some real site pictures where we are using tile adhesives. Okay, there is we are using tile adhesive and fixing. There is if you see, there is a large size of tile. It's things I think it's a 6 feet by 6 feet by 4 feet tile. And they're fixing it. These, if you see the tile adhesives, these are the notchings. These knots are given by a notch travel. These are like tile adhesive will look like after mixing of cement. You see how the cement looks. Tile adhesive will look similarly, but you have to give knots like these kind of lines you have to give, so that in both in tiles and also the substrate, so that they will lock properly the tile adhesives and the substrate. Okay. From the beginning of my slide, I show you what is notching. Yeah. Yeah. If you see here, these lines are the notch lines. Let me. Yeah. These are the notching lines. Okay. There is a special trowel available in the market to prepare this notch. Okay. I will show you the notch trowel also. Yeah. Yeah. Yes. These are the notch trowels. If you can see here, this is giving a more clear picture. See, when we run this travel, it will give this kind of notch. It will help to lock the tiles in the software. Okay. So big tiles are now being used, and if you see in the middle picture, in the gaps of tiles, these are the between the gaps of tiles, we fix the spacers and fill the gaps with epoxy tile grout. These are heat resistance, water resistance, and chemical resistance. They are also food grade. So what happens? It will resist any kind of chemical, dirt, or any water to enter into the soft like your floor. So it also work as a elastic membrane to between tiles. So it also take care of the extraction contraction of tiles and stones. These are the tile grouts in between. If you see, tile grouts are come in different colors. You can choose any color as per your requirement. Here, as he is using here this golden color tile adhesive. Okay. Now I'm showing a video. These, if you see these yellow things, triangles are labelers. They are used to, because after flooring, the floors maybe have undulations. To keep tiles on level, we use this kind of labelers. And here there are different 1 mm to 4 mm. There are different hooks are there. You can fix the hook at that there, and it will hold the tile up to 2 mm, 3 mm, 4 mm, and you will able to fix the tile. Let's see how this person do it. Yeah, this is the vibrator we use in tiles. Yeah, I think the sound is shared or not. You can hear the sound of this video.
Yes, the sound is not clear.
Okay, let me see. Hmm. Now I think sound is, you can hear the sound.
Yes,
Yes.
yes.
The vibrator is for fixing tile adhesives and in tiles. It will flow the tile adhesive in weak tiles beneath the. These are the labelers. Yellow color. These are the labelers. They are meant to fix. Yeah. I think these the yellow colors are the labelers. If you see, there is a white line. There is a white color pin is there in the entire yellow. This is a triangle. Here is a 0.5 mm to 4.5 mm triangle is there. Height is increasing. You can fix it white color in 1 mm, 2 mm as per the level you want, and it will hold the tile at that level. Then you then you apply, pour the material and apply the vibrator to fix the tile on the same level. Yeah. So I am showing some project. This is a Marriott hotel project. This is a Ram Mandir in Bilaspur. This is a famous mandir which is recently opened during Durga Puja. And one of the Shankaracharya came for 3 days here. And here you see there is a polyurethane type 5 tile adhesive used to fix these aluminum panels. Aluminum panels on the walls and tiles. Okay. Here there are different type of stones written with Ramcharit Manas and Hanuman Chalisa and all these things. They are used to fix with the fix upon the white cement wall in this mandir. So these are the advanced construction materials we use in different type of requirements. Okay. Yeah. This is the test I was saying. These are 50 mm by 50 mm small tiles. This is pull out test for tensile adhesion strength of the tiles. As you saw, na type 5, type 1 should show the 1, the type 2 should show 1, type 3 should 1.5. These are the ways how we check the tensile adhesion strength. This machine itself cost around 2 to 2.5 lakhs. And if you see, we apply the tile adhesives and tiles with the tile adhesive 50 mm tiles. Then we let it be set for 7 days or let it be 28 days, and there is we can do it 7 days also. And after that, we will fix these. These are called dollies. Over this tile adhesive, we will fix a dolly, uh, dolly, and which will be pulled, which will help the machine to pull the tile. The lever, the machine, if you see, this is this is the lever which will hold this dolly and pull the tile. And after this will show the strength how the tile adhesive will break. Okay, is 1.8 Newton per mm square. After 1.8 MPa strength, the tile adhesive loses its strength, and the debonding happened between the soffit and tiles. Okay, I hope you understood how we do the process. I will show you a live video also. But you understand, this is the process. We 50 mm by 50 mm tiles fix on the concrete surface with tile adhesive. Then we fix the dolly, which will help the tiles to pull with a lever, and it at 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 what load the tile adhesive leave the substrata and tiles will known as the tensile adhesive strength of this tile adhesive. Okay, let's look at the test. Yeah, see the tile after some strength, the tile, and this is the let's look at the next video. This is how you see how the tile debond from the substrata and the tile adhesives break at 1.30. Okay, this kind of test we do to ensure the strength of tile adhesive. Okay, these are some recent projects are used in Odisha, nearby areas. You can see hospitals. This is Capital Hospital, Jedwan Estate, Royal Heritage, Sambalpur, Sky City. And if any one of our professors or teachers want to experience this, they can contact us, and we will arrange a demo, or we have many excellency center of excellency made in college laboratory also. We will have a real application and testing for them and our final year students also, so that they can have a real flavor of this. Okay, and if possible, if our client allows, we will arrange a site visit also. Okay, recently Taj Hotel Puri, we have used tile adhesive. These are fixed with tile adhesives. So the different aesthetics you see of stones applied outside of a building are used are fixed with tile adhesives only. Okay. So let's move towards waterproofing. Again, waterproofing is a very vast subject. I say 6 7 days also we used to do course on it. But in waterproofing, I will only touch on very basics and why waterproofing is required and what only new constructions I will say and why waterproofing is required and what are the areas we will do waterproofing. Like tiles, I told you all the IS codes, how what are the types of tile adhesives, and how we use tile adhesives and all these things. In waterproofing, I will just explain in which areas you should use waterproofing. Okay. So shall we start regarding waterproofing, or we need a 2 minute break or something like that? Or Pankaj sir, do you have a break in between for the next speaker between
No,
my
there is no break, sir. Immediately, the second session will start exactly at 7:30.
so I think let's give a 2 minute break to our participants, or in between I can take questions on tile adhesives also. Okay, so that
You,
for moving
you can
towards
have
waterproofing,
you
yeah,
can have a questionnaire session, and it is my sincere request to you,
yeah,
because
yeah.
the other expert he will exactly join at 7:30.
Don't worry about that. This session will conclude in 15 minutes max to max, because I'm not going into detail into this waterproofing. My main focus was in tiling and all these things. Waterproofing, it will not matter that we can close it, but in waterproofing, I will tell the importance of waterproofing only in new construction. Yeah.
And some participants may have some questions, so we can allow them for 5 minutes
Yeah,
for question session.
yeah, network is so kindly request to share the printer. So the presentation will be share. Yeah, okay. There is no such questions in the chat. Yeah. Any questions you can put in the chat, and coordinators can be send the questions to me, and I will be very glad to answer all your questions. Saying so, I will end of this presentation. I will share my email ID also. You can write down your questions. Okay. Any questions? The forum is now open for questions. Yeah.
Is there any question from the participant side? No question, sir. You can proceed.
Okay. If there any question, you can mail me. So waterproofing in new construction. Yeah. So mm, why people investment their savings because more for maximum the people they build home for once. They invest their life saving in building a home, and we engineer have the responsibility to to ensure that they will have a durable home. Okay. So how this will go? Yeah. So in every, I say 4 out of 5 homes, there will be a problem like this: waterproofing problems, rising dampness, corrosion of steel bars, leakage, and dampness. Okay, these things, if these things only after structural damage. Okay, if there is no structural damage in the structure, the water will enter into your structures and make the durability uh, less, or the lifespan of the structure less. Okay, so maybe climatic change and fast speed of construction, lower time. Okay, so how to avoid these things in waterproofing? Okay, so there are external factors beyond our control. if we choose proper material, proper vibration, and proper construction method, also there are many external factors which are beyond our control to, like shrinkage cracks. They may be naturally develop in cement, lead in these cracks, water may enter to the structure or building, and corrosions happens, efflorescence happen, all these things. Thermal crack due to temperature variations. You see, India is the only country having a temperature of 0 degree to temperature of 48 to 50 degree, like this. So these kind of temperature variations also lead to thermal cracks. So these cracks may lead to enter water into the structure and develop structural cracks. So what is the solution? We have different type of waterproofing materials. We just need to know if in new construction we have to do two type of waterproofing. One is integral waterproofing and another is layer waterproofing. What is integral waterproofing? During the construction, we have to mix the waterproofing material with the construction material. When we are doing concrete, we have to mix this integral waterproofing liquid with the cement to make the concrete waterproofing from within. Like we take vaccine for the uh, for corona, says for any disease, we take vaccines. It's integral waterproofing, like that. We integrate the waterproofing compound with the cement or concrete to make the things waterproofing within, which will reduce the shrinkage crack. And also when we add a integral material, waterproofing material to the concrete or plaster, what it will do, it will reduce the porous and water entries and all these things, so that the concrete gains more strength and resist to corrosion of steel. And layer waterproofing, what is, as the name says, it's a layer. As I say, we use masks for prevention from corona. Like that, we use a layer over concrete or wall to prevent water enter into the structure or the building. Okay, so these are elastic layers, and we have to choose these layers, this material, as per the vibrations, as per the thermal expansion contraction. There are different type of material. So in the general in a new construction, this is enough. We have to use integral waterproofing and layer waterproofing. Okay, so in which area of enter building we don't need to do waterproofing, but in which areas of the building we have to do waterproofing. Okay. So the first area, I will just explain these 5 points. In first areas, this is the below the ground area. If you see DPC level, from DPC level, what happens? Water rise through capillaries, and capillary rise of water will make the path of groundwater to enter into the walls, and this will lead this kind of problems, erosion and all this. To avoid this, we have DPC waterproofing. There is a layer, bitumen layer. Suppose bitumen layer waterproofing is there, you have to apply this bitumen layer before ground filling over the DPC level, DPC layer, and it will act as a preventive layer between groundwater and your substructure. So it will raise the it will block the groundwater to raise through capillary force to your substructure. Okay, this is for foundation level, DPC level waterproofing. Okay, this is the point one. Here we stop the groundwater to enter to our home. Okay, then yeah, this is a real scenario case. This is our HDFC Bank from Balesur. What happens there? Because this is their basement area, and here there is a electric panel is there, and water leakage happened due to capillary rise. And this is a moisture meter. You can see that this is a moisture meter which shows how much water percentage is there. You can see this is 25 in the meter. Okay, before application of waterproofing layer. Then we do the treatment and apply a cementitious waterproofing layer. Now see, it's below 10, the moisture percentage in the wall. So obviously this higher moisture content may lead to risk because the electric panel was there. So this is the treatment we did in HDFC Bank. This is a real case. There are many real cases, but I kept these two no for this is important for new constructions. Okay. Yeah. For bathroom kitchens, these are the water prone areas where more water pipes are laid and all these things. So for bathroom and kitchens, we must do a integral waterproofing in the bathroom slab. Okay. Then there is a layer waterproofing we have to do before applying of tiles, or it's better to before applying of plaster. You do there is a layer waterproofing, different type of layer waterproofing available. Cementitious layer waterproofing available, and आपका resin based layer waterproofing also available. We can apply this waterproofing layer over the brickwork. You can see the arrow is there over the brickwork or the plaster. Then you apply tiles. Then it will seal the waters to enter into the structures, and this kind of things are prevented. You can see after 1 or 2 years of construction, this kind of nasty things you see in every home. And also when the bathroom water leaks to outside, there are development of fungi and different type of organic things will happen in your structure, and it will weaken your structure like hell. So this is the second area we should do waterproofing after DPC layer waterproofing, bathroom and kitchen. Obviously, roof is exposed to direct water. When water move through the pores of roof and seepage happens beneath of the roof, it will corrode the our reinforcement, and with corrosion the steel expands, and due to the expansion the concrete spalling happens, and it will lead to different structural failure. Even if after 4 5 years also we have to demolish the entire structure, because if a roof is in structural failure condition, the life of the residents come into stake. So in roof area, what kind of waterproofing we have to do? Again, we have to do integral waterproofing in the roof and apply the layer waterproofing over the roof and the parapet wall. Then apply a skidding layer over it to protect the waterproofing layer. And also there are very different type of waterproofing layer waterproofing is available. You don't have to do any skidding over it. So we have to do waterproofing in the roof area. Okay. So this is a innovation work we do. This is Jagdalpur railway station. We have East Coast, as I saw, East Coast Railway has approached to prevent the preventive measure for their one of the old structure. So this is a colored waterproofing layer, and this is a acrylic layer you see, and this layer don't need any kind of protection. It can last up to 20 to 30 years for waterproofing. Okay. For exterior walls, yeah, for exposed to rain and extreme harsh climate areas, you can do exterior wall waterproofing. But these things, I think, exterior wall waterproofing is required. Uh, the areas like where your plumbing pipe is there in the outside. So in these areas, only exterior waterproofing there. In other areas, you don't need to do exterior wall waterproofing. And what is the this to avoid this kind of corrosion and things, we should do integral waterproofing in columns and beams, so that I previously explained what is the importance of integral waterproofing. So these are these areas as I explained. This is a summary in foundation. In structures, we have to do integral waterproofing. In kitchen and bathroom, we have to do layer waterproofing. In terrace, roof, and swimming pool, these are these hype areas where you have to do waterproofing. These are the different product available in Ultratech. I don't want to emphasize the product. You just need to know that there is a bitumen-based waterproofing available for DPC foundation level, integral waterproofing for columns and beams, and there are cementitious waterproofing and acrylic-based waterproofing for roofs and balconies. Okay, yeah. So that's all from my side. Yeah. Thank you so much. You can note down my email ID. Is mentioned here, soumya.rnaik@itbilla.com. Yeah, my LinkedIn ID is also with Synergy team. For later, I think they will share. Yeah. You can note out my email ID to send me any queries. I will more than happy to answer it. Yeah, I also put my email ID in the chat. Okay. Yeah. Thank you, Pankaj sir, and thank you all the participants for your patient sharing. And I am very happy that from the beginning of session, the participants have increased to the end of the session. Okay. And generally, what happens that participant count degrades, but it's increased. Yeah. Over to you, Dr. Pankaj.
So, thank you, sir. Any participants? We have 5 minutes in our hand, and if you want to ask any doubts, you can just discuss with engineer Soumya Naik, sir.
Sir, kind attention here.
Yeah. Yes.
It's a very good presentation.
Thank you,
Sir,
sir.
why there is always a difference of example guarantee or warranty period? Generally, whenever you apply some coating elements or whenever you use different types of products are there.
Yeah.
Why all the product does not have a similar lifetime? That means the durability of each product is differs. What is the reason for that, sir?
Yeah.
Because all
Let me-
the things are
yeah.
manufactured from your end. No.
No. The manufacturing is a different thing. Let's don't go into the manufacturing thing. I am telling you the basis of the materials. Suppose there is a cementitious waterproofing and there is a acrylic based waterproofing. Okay. So in acrylic based waterproofing, there is the thing has more elasticity. If the water pressure and these are measured with water bar. 5 bar water pressure, 10 bar water pressure. The different materials, acrylic based waterproofing has more elasticity, so that this membrane, after applying a waterproofing layer, it will work as a elastic membrane like plastic sheet on your structure. The more elasticity the membrane have, the most warranty or guarantee you will have. Okay, that's the differentiation you get in terms of warranty and guarantee from the products. Okay, obviously manufacturer will give the different warranty and guarantee, but these depend on the crack bridging ability and this elasticity property of the waterproofing layer. I hope I answered your question, Dr. Vijay Sarth.
Okay, thank you, sir.
Yeah.
Okay. Thank you, sir, very much for your nice presentation.
Thank you.
And as you shared that real practical visit is very important for this. Also, you have invited to not only us, other institute members also. So definitely we'll uh, make a visit to your sites, and the students as well as faculties will definitely gain some knowledge and technical skills from that. So it was a nice presentation by Engineer Soumya Naik. Now I request and our expert and will take permission to stop this program for this session.
Yeah, thank you so much. And there is a last question is there ki good quality assurance. Yes, the company I am working in Ultratech, we have a dedicated technical support team. Their job is to give you quality solution regarding the construction, and their job is to give you the construction process to assure the quality. Okay, so our job is to give you guide you with the process. So please reach out to us, and our dedicated team will help you to assure the quality of your construction. Okay, and also we do different type of sessions, also practical and all these things. We will help you through that. Yeah, thank you.
Okay, thank you, sir.
Thank you. Okay, best of luck for the remaining sessions to all of you. Okay, saying so, goodbye, best wishes.
So, sir has 30 years of experience as well as he has, he has published 5 papers also. So, so participants are requested kindly to mute your phone. All the participants are requested to mute your phone. Participants are requested to mute your phone. Sir is going to deliver her talk. So this is all about our this participants are kindly requested to mute your phone.
Devi Prasad sir, kindly mute.
Co-coordinator
I
madam, Mosu
request
madam, you
Devi
are
Prasad
requested
sir,
to
kindly
give.
mute your audio. Devi Prasad Pandya sir, kindly mute your audio.
This is a FDP program. Please bear with us. You cannot discuss your homely matter here. So, sir, I welcome you to this session, and sir is going to deliver on a very good topic. This is our second session of the day 3, and the topic is application of advanced materials in soil stabilization, which is a key to sustainable ground improvement for construction. I welcome you, sir, again to this FDP program, and I request you to start the session, sir.
So with your permission, I will share my screen.
Sir?
I am sharing my screen now.
Yeah, sir. Yes, sir.
Is my screen visible to all?
Yes, sir. The screen is visible, sir.
Okay. Like in case if you miss to see anything, then you do let me know during the presentation itself, because I won't be able to take that as a note. So thank you very much, Synergy. It's a great event, and in fact, this is one of the most favorable time for me to chat and interact with the faculty members who are basically developing the new generation in the field of civil engineering. So we will be talking about the soil stabilization in particular, and which is a ground improvement, and how that is going to impact the topic which is being considered for this particular 5 days program on faculty development by Atal. See, the objective is, of course, we talk a little about the transport system, the road network which is available in India, benefits of the good transport system. Once we cover that, then we will talk about the soil stabilization in particular, use of soil stabilization in flexible payments, benefits of soil stabilization, and then finally we will end up the session with a case study on the BC soil, which is one of my PhD's topic also. Now, to start with, generally we all know, which is the transport system is basically the movement of people and goods from one location to another. And there are basically four major types of transports, which is rail, road, air, and water. And in this particular session, we will be talking on road. Again, the road is divided into flexible payments and rigid payments, whereas in our case, we will be focusing more on the flexible payment only. If you see the growth of road network in India since 2012, the initial rate of growth was 12 kilometers per day, which has moved up to 29 kilometers per day in the year 24-25 by after touching a peak of 37 kilometers per day. See, what is the meaning of 12 kilometers per day road construction? So actually, what happens is that much of data, that much of resources is required, that much of material is being consumed in the construction of road network only. With the advancement of Bharatmala, with the advancement of national highway, expressways, networks, the demand is exponentially grown up, and then people see the benefit also of good road networks. I I remember like during my initial days when we used to travel in a two-lane road, which is at that point of time was called as a national highway. But in 2000, we have constructed that two-lane into four-lane, and that four-lane itself was a magic for us. But now, in today's scenario, that four-lane becomes a two-lane, and now we are expecting six-lane and eight-lane roads to connect the metro cities and then the intermediate cities to boost the transport system. So this is the level of growth which is expected. And if you see the benefits of a good road transport system, you definitely save time in traveling. You definitely have a better freedom to travel. You basically, your dependency on the specific modes of travels, like earlier we used to have the dependency more on the train part, which is being reduced drastically nowadays. People can plan immediately, and they can choose any road to reach to their destination with much easier than as compared to other things. So if you take a note of what benefits we normally get, we have already started getting these benefits. That when you increase the speed of construction, you increase the speed of connectivity, you reduce the vehicle's operating cost because there is no much of activities to be done except the control the vehicle in a cruise mode, and then saving lots of time for the passenger to move from one location to another. Reduction of accidents. Of course, this is a point which is debatable in nature, because sometimes even a dead road become the cause of an accident. So there, but of course, it is a type of accident which is not generally seen in case of a two-lane or a single-lane national highways. Of course, it increases the comfort levels, the better national integrations, the national security, because as you increase the speed of movement, you are decreasing the risk of non-attainment or non-achieving any particular goal in particular. If you see the cross sections of a flexible pavement, you generally have two layers of asphalt on top. One is DBM and the second is BC. Below that, you have wet mix macadam, WMM we normally call it, GSB, the granular subbase. Then you have a subgrade and then embankment. Each layer has their own configuration and their own role to play in the construction of a flexible pavement. So the idea of what it is when you construct a particular section of flexible pavement, you consume certain quantities of the materials which is used in general to construct the road. Like for example, when you talk of embankment, it is the soil material. When you talk of subgrade, it is the soil in majority which is being used in the construction. When you talk of GSB, WMM or DBM layers, there will be an involvement of the naturally available rock materials or the aggregates which are being crushed and used in these layers to strengthen the flexible pavements. So what we intend to say is like the moment you move from GSB and above, you have the consumption of the naturally available aggregates, which is increasing day by day because of the speed of construction from say 12 kilometers per day to 37 kilometers, or at least in the recent stages, if you see, it is close to 24 kilometers per day. That means what? The demand for these aggregates is doubled. And when the quantity of the road is also increasing day by day, that means the consumption of these materials is going multiple times. But we don't have that material because there is a limitation of the natural aggregates. And that is what is basically creating the demand for the sustainability in particular. If you want to build, because you cannot stop building roads, you cannot stop building uh, expressways or highways, or you can say, because that is giving you the faith and the comfort for the people to move from one place to another. So that is anyway, because you got that taste to travel by road, you cannot stop that. But at the same time, you have the limitation to use the aggregates available. So then there is a need for how to build a sustainable road without consuming much on the naturally available aggregates. Or alternatively, you can say how to build a good quality, durable roads with minimum use of naturally available aggregates. So if you see that the quantum of materials required for different thicknesses of DBM, BC, WMM, GSB or subgrade, a total of 42,252 metric ton of the quantity of material is required in total for making a 6-lane road. This is the quantum which is required. Now, multiplied by the length of the road, if you see, then definitely it's going to be huge. So that means what? You cannot neither stop building the road, nor you can ignore the availability part of the material which is suitable for constructing a particular road. So the challenges in the today's road construction, if you see, is increase in construction speed from 12 kilometers per day to a current rate of 29 kilometers per day, by touching a peak of 37 kilometers per day. That means what? It has already constructed so much of road and consumed the available natural aggregates. Now the balance remains will be very marginal, and which is going to have a difficulty in reaching the required quality parameters to build a sustainable, durable roads. So this has impacted the availability of the suitable soil or the aggregates part. Now, in order to address these challenges, what best could be done is you can have an optimized payment design itself, or which will lead you to the options like you can use unsuitable soils in the road construction, or you can use the existing in situ soils to its maximum required level, so that you will get an improved CBR, because CBR is the basis of the pavement design. If you look at the IIT PAVE model of flexible pavement designs, which is a 3-layered structure wherein you can see you have a subgrade layer where you can get the effective CBR to be calculated and submitted as an input for the flexible payment, and then you have the E values and the Poisson's ratios of the GSB or the WMM layer, which is again acting as a single layer, and then you have an asphalt layer, wherein you put the MR values and the Poisson ratios. So the idea is when you improve your CBR, what will happen to the other parameters, whether the road which is being constructed is, when evaluated or analyzed using IIT PAVE, whether it is safe in terms of rutting and fatigue parameters as mentioned in the design calculations, or it is failing to achieve those things. So once you see the improved MPR or improved CBR means what, we have we have done this calculation on IIT Pay only, and it shows that in the first column, if you are able to see, like just give me a minute. If you see this first column of just immediately after the serial number, you know this is the E value or the MR value of the asphaltic layer or the top layer. If you fix that layer thickness as if you fix this value as 3000, and then you start doing the calculations on IIT PAVE and you start your CBR of subgrade, effective CBR, in fact, in this particular case, I'm taking the effective CBR only. And when you see the effective CBR is moving from 8, 10, 12, and 15, of course, if you look at the IIT PAVE, your effective CBR of subgrade should not be more than 15, because even if it is more than 15, it is not adding value to the mixed design, because the deflection value or the K value is fixed at 100 MPa there. So forgetting about that parameters, if you see, like if you increase your CBR from 8 to 20 for the same MSE, you can see that your total crust thickness is reducing by 5 millimeters. 595 will become 590, 590 becomes 580, and then so on up to 550. Meaning what? When you increase your effective CBR of the subgrade by 2%, your total crust is reduced by 5 millimeters. Now, which one is the costlier material in this particular case? Of course, the bituminous layer is the costlier material in this particular case. And if you see the next column, we have reduced the bituminous layer, that is DBM, by 5 millimeters each. Now, when each layer of bitumen is reduced by 5 millimeters, the quantity of binder used in this particular case is reduced. So that means that much of less production is required to build a 100 kilometers of road. And then, of course, the aggregate part also. The meaning is, if you see subgrade in the natural condition, it's quite possible that you get a particular area, you get a CBR of 8, somewhere you get a CBR of 10, somewhere you get a CBR of 12. Maximum what you get is 12, not more than that. Because I have seen this in my 30 years of experience. I have not encountered a soil which has a CBR of more than 12 to 13. So the idea is, if you are able to, sometimes it is less than 8 also, like it goes to up to 4, 5 also. So the idea is, if you are able to handle your soil parameters, and if you are able to freeze your subgrade of CBR to say 15 by any chance, then what is magicable is you can always play with your asphalt layer, and you can reduce your DBM up to 65 instead of 95. That means there is a reduction of straight away 30 millimeters in the construction of the asphalt road. And if you reduce your asphalt layer by 30 millimeters, your production quantity is reduced, and your per ton cost, which is close to 12,000 to 13,000 rupees these days, will have a huge impact on the production itself. The production part, the transportation part, and then the laying part. So this way you can have a cost benefit analysis, and then you can ensure, yes, there is a benefit if you are doing the soil stabilization. Similarly, if you plot a graph also, the results will be but obvious, because but in this particular case, what we have done is we have chosen different MR values in the x-axis, and we try to plot the different graphs on different CBR values. Like the bottommost line is of CBR 20, and the topmost line is of CBR 8. Means what? When you have a less CBR value, your crust thickness is high. And when you are moving from 2000 MR to 3000 MR, even if you increase your MR value from 2000 to 3000, that is what 1000 values. If you are increasing you are changing your MR value by 1000, you are able to reduce your crust thickness from 615 to 595, that means 20 millimeters. So for every 500 MR value, you are able to reduce your asphalt layer thickness by 10 millimeters. So there are two ways to handle these situations. One is either you do a design of a higher MR value, and to achieve the higher MR value, what all the requirements are, because MR value is again depending upon the type of the aggregate, type of the binder to be used, and then the mixing of those two. And of course, if the type of the aggregate is not correct, then you need to go for a higher performance grade or PG grade or PMB type of binders instead of VG30 or VG40. So these are the things which you need to choose effectively and understand how this is going to be cost effective without compromising on the durability aspect of the asphalt roads. So I will skip that slide because that is similar to the previous surely shown slides. So that is what is I am trying to skip up. Now, when you talk of improved CBR, so like for example, I have just taken one example wherein I tested a soil of Fatehpur, which is having an original parameter. It's a silty plus clay is 56.87% with an MDD of 1.873 and OMC of 13.74. The control soil sample has a CBR of 8%. Okay, but the moment you start adding the cement on this particular soil, ranging from 0.1, 0.2, 0.3, 0.4, 0.5, and up to 1%. And if you are curing it for 4 days, 7 days, or 4 days dry and 4 days soaking, sorry, excuse me, you can see the results. The 8% CBR, when you are adding only 0.1% of cement, your 8% CBR becomes 8.64 on the 4th day, 9.56 on the 7th day, and 10.02 on the 11th day, because 7 days dry and 7 days soaking. In the initial 2 times, it's 4 days soaking or 7 days soaking. So similarly, when you increase from zero point 0.1 to say 0.5 or say 0.3 or even 0.2, now when you are particularly using for subgrade, your subgrade requirement is your subgrade material should have a maximum of CBR of 15% only, because beyond that, whatever CBR you do, it is only adding cost, it is not adding any other value, because it is not going to change any other parameters of your design if you are doing the design on a 3-layered structure using IIT PAVE. So if my cement doses are 0.2%, then the cost, then the material, the CBR, which is supposed to get is 16% at the end of the 11th day. Now, there is an important point to be noted, like if you are adding cement 0.2% and testing immediately the next day, it's not going to be close to even 8% also, because it will be less than what the control sample is. So that is why there is a need to cure the stabilized soil, especially when it is being stabilized using cement. When you are stabilizing these things with a mechanical method using other than the cementitious materials, then this is not going to be that critical. But when you are adding cement, curing plays a vital role and it adds value to your strength, thereby optimizing the doses. People normally go for 0.4%, and then because they don't want to wait for even 4 days, they say 0.5% you can add, and then even after 2 days also you get 10 to 12%, which is close to 15%, so we can manage. But that is not so, because initial period of the soil is not at that matured level to take any load. And if you are not meeting basic minimum criteria of minimum 4 days, or then the whole structure is basically getting segregated, and thereafter whatever time you do, it's not going to increase your strength parameters. So what we normally do in field is, if whatever the values are, my expected value is say suppose 18, and if I'm adding say 0.3%, I know on the 4th day I'm getting 10. So even after a 4th day, if I'm getting 10 also, immediately after fourth day, I can start using this layer for the next layers, because 8% CBR is good enough to take loads of loaded vehicles. Because generally we design based on your 8% CBR also. So that is the bare minimum thing we generally keep in mind when we do the soil stabilization. So soil stabilization is a procedure wherein the engineering properties of the soils are altered or enhanced to increase its suitability for construction purposes. And soil stabilization is a controlled modification of soil structure and the physiomechanical properties of the soils. The major reason for performing the soil stabilizations includes it improves the strength, it achieves the dust controlling, it also acts as a waterproofing material, and it promotes the use of waste material in the construction. It all depends basically how are you going to do the soil stabilization, because it's not always possible that your natural soil will meet all the requirements. Sometimes the liquid limit is more, sometimes the plastic limit is more, sometimes your free swelling index is beyond your control. So the stabilization will not only increase your CBR, but it also has an impact on the other engineering parameters like the Proctor values, the liquid limit, the plastic limit, and so on. So there are different methods available. We have a standard wherein you can see different methods available, like biological soil stabilization or physical soil stabilization. We call it a mechanical soil stabilization, and also we touch upon the chemical soil stabilization. When we talk of biological soil stabilization, it is achieved through afforestation or planting, and its main purpose is to control the erosion, which we normally do on the sloping portion of the high embankment portion. That is also a type of stabilization only, because we are trying to uh, control the erosion. We are trying to, because water is such an element which reduces the shear stress between the particles, and once the shear stress goes low, the movement gets faster when it is on a sloping roof. So even the biological soil stabilization will have a different role to play, but of course that is being achieved through turfing in general, in the case of the construction of highway materials. Then, when you talk of the physical soil stabilizations, it is the modification of soil particle size distribution by adding or subtracting a certain quantity of materials to the extent required. Like generally, your liquid limit and plastic limits are depending upon the percentage passing 75 microns and 90 microns. The moment your percentage passing 75 microns and 90 microns is beyond your control, your liquid limit goes up, your FSI goes up. So the other method is you take proportions of two soils. One is very good and the other one is below average. So when you mix in right proportion the two types of soils, you get a third type of soil which will meet the requirement. So that is what is basically we talk of physical soil stabilization. And in this particular case, you don't need to wait for the curing period, because there in this particular case you don't need a curing at all. Similarly, when you talk of mechanical soil stabilization, it is the modification of the porosities and the interparticle friction or the interlocking of the particles between the two types of soils. And when you talk of chemical soil stabilization, which is greatly being used in majority of the road constructions, we generally use lime, cement, and fly ash in particular in the construction of the roads, but that is not the only thing available which can be used. So anything which comes to your mind and see that whether it can increase my properties or the engineering properties of the naturally available soil, that can be used as a sample base or as a laboratory study to understand the deviations which is supposed to happen by adding those materials. So cement is one type of soil stabilization where you can add a cement ranging from 0.1 to maximum of 2%, or you can go beyond that also in some cases where we need the UCS values also to become a parameter to consider. So, but at any point of time, we have not used more than the 3.5% cement to achieve the required CBR. CBR is anyway you get by adding more than 1.5%. But generally, the higher cement is required only in case when you are supposed to address the UCS values also uh, being a requirement. Generally, it ranges between 1.25 to 1.5. It should be more than 1.25 to 1.5 for highways and expressways. So if it is able to achieve that, and then for that particular reason, you need to go close to 2.5% of cement stabilization. But the purpose of the stabilization is again same thing. The method of stabilization we will be discussing in the different sections. Now, in this particular case, we will just touch upon what all the different types of additives or the minerals I have seen, and some of them I have used in soil stabilization. Fly ash, it's again a byproduct of the thermal power plant, which can be used as a stabilizer. It's generally the pond ash is generally used as an embankment material, so it is a lightweight material having MDD not more than 1.3, 1.4. But when it is being added to the soil with a high liquid limit or plastic limit, the beauty is it is able to control the liquid limit and the plastic limit. But the issue is you cannot go beyond 35% of the fly ash, because even if you add beyond 35%, it has got no impact on the change in the liquid limit or the plastic limit. So the resultant is you are not going to achieve higher values of CBR or anything else. So the bottleneck is you can use fly ash, but then to an extent maximum of 30 to 35%, not more than that. Emulsion I have not used, but I had seen people using emulsion as a soil stabilizer. I didn't get the opportunity to use it, but again, emulsion is also a material which is being frequently talked of to be used as a stabilizer. Generally, NHI or the highways recommend the use of these emulsions in the shoulder portion, which is being laid after the curb casting, so that you can spray the emulsion and it will percolate through the gaps or the pores available between the soils, and it will make a bridge so that it will hold the soil in its position. Rice husk is one more element which is we tried and tested in one of our projects in Bangladesh, where the rice husk was used. It's again a fibrous material. The availability is of course an issue, because you cannot add anything and everything into the soil, because then the length of the material being used, then the particle size, all those things matters a lot. But rice husk is one of the material, if you get in the right proportion, in the right size, it's definitely is going to add a value, because it is a binder sort of thing which holds the two particles of the soil into one place and adds value as far as stabilization is concerned. Sand, of course, is generally used to increase your MDD and the CBR directly. Of course, it reduces the CBR, it reduces the liquid limit and the plastic limit. Again, the free swelling index also, because without decreasing these parameters, you will not be able to achieve the required CBR values. Lime is a material which is generally used when you are basically trying to when you are basically trying to stabilize a higher clay content soil, because clays are such materials which needs a material which will absorb the extra water which is available in it and make them compatible and then mix it properly. So generally we use lime whenever there is a higher soil with a higher liquid limit, because then lime plays a similar role as fly ash, but the only difference between the lime and the fly ash is not a good absorbent of water, whereas lime is a good absorbent of water, but the particle size are almost close to same. Then we talk about nanoparticles. This is one of the topic which is very close to my heart, because I had done the research on this particular material only, and my PhD is all on the stabilization and the particles, nanoparticles reaction with the different types of black cotton soils. So this we will go talk about in detail in the case study part. And then, of course, if you have a good soil, you don't need to go for a soil stabilization. But I have considered good soil also into this particular scenario, because even if it is the CVR is 8%, as far as the most specifications are concerned, the soil is suitable and it's considered to be good soil. But my intent is, whatever the type of the soil you achieve, you encounter during the execution stage, if you are freezing your design parameters with the 12% CBR of the subgrade, then no soil is a good soil. Every soil needs to be treated. And so that is the reason why I have taken good soil into the framework of the soil stabilization. Because the moment you stabilize your subgrade soils to 15% constant, irrespective of what type of soil you have, because if you have poor soil, your doses will be higher. If you have a good soil, your doses will be less. That is the only difference. But your entire road will be designed on a single CBR, that is 15%. Now, the beauty of this is you will be able to reduce the other things which will be cost effective. And even by adding, by doing stabilization, whatever the additional cost is being incurred, that is not going to be more than what is being saved. So this is what is basically the summary of the soil stabilization framework. Now, when you talk of a process of soil stabilization, this is how we normally do in sites. So we make the grids of the entire road, which needs to be stabilized. We lay the soil which is not suitable, do a plain pass, prepare a grid, and then use the cement bags on top of it. The cement bag calculated for each grid is being placed in its position and then spread out. The idea is, theoretically, you are assuming it is 0.1%, 0.2%, 0.5%, or 1% or 2%. But how are you going to ensure that in the field? So there needs to be a process, there needs to be a procedure in place when you are doing the soil stabilization. So the first step is the grading, second step is the calculation, third step is placing of the bags as per the grid lines, and then open the bags and spread it across. This is method which is generally manual in nature. You have equipments also available wherein you can use the right doses. You can calibrate the equipment for the different types of doses you want to do the stabilization. And then instead of placing the bags, you can run the equipment on top of this particular soil, which will do nothing but harrowing and mixing. So this step of spreading manually can be eliminated when you are using a mechanized way of stabilizing the soil. Generally, RM300 we use in different types of projects. So in that particular soil, you have a tanker running in the front of the uh, machine, which carries the is basically not the tanker, it's the bulker, which carries cement, which from where the cement comes into the machine and spreads across, and then it goes in. This is the location of the harrowing arrangement, wherein the complete soil is being ripped and then mixed, so that your initially compacted soil is now burst by, say, another 20, 30, 40 millimeters. So this is the first step which needs to be done after the spreading of the soil, and then you can roll it and then compact it. So what all the benefits of soil stabilization? The benefits, if you talk of like one is the saving of the natural resources. When you talk of natural resources, it is the type of aggregates available, type of soil available, suitability of soil, suitability of aggregates, all those things. Of course, it has a direct impact on the suitability of soil, but it has an indirect impact on the natural aggregates, because aggregates are being used in GSB, aggregates are used in wet mix macadam. The same aggregates can be used in DBM and BC also. So the moment the sections, the pavement design cross sections have changed because of the CBR of the subgrade soil, every parameter, every matrix will change, and then will lead to a good carbon footprint. When you talk of the life cycle of this particular soil stabilization, right from the production to the consumption of the materials is being saved, and the carbon footprints can be calculated on that particular areas. So use of unsuitable materials, of course, this will add value to people to understand, yes, there's nothing called unsuitable material. Any soil can be stabilized and used in the road construction. So the terminology of unsuitable soil can be eliminated permanently from the course. Rather than talking about unsuitable soil, we can make them how to make it suitable, so that the other terminologies can be used in a positive sense. And then, of course, you have the improved durability aspects. If you can add uh, rut resistant materials, you can add UCS values, UCS parameters to ensure that, yes, there is an improvement in the durability of the roads, and roads are not going to be affected because of the presence of, or because of the percolation of the water from different cross sections. Then you need to adhere to the timelines, because generally people lose time in search of good materials, whereas if you know that you don't need to search, you just need to rip the available material, test the available material, arrive at a parameter, choose the methodology, how are you going to do the stabilization, and then do it. Then there is nothing called time loss. You only need to plan your work in such a way so that your curing period will be adjusted in the other activities, and you are able to execute the work with maximum benefits. Generally, we talk of 4 days or 5 days of curing, though in the standards it is 7 days given. But even if you at least do 4 days or 5 days, it's going to help you a lot, because that 4 days curing, if you require for a particular stage, what is more required is you need to have 4 sections to be ready for stabilization, so that by the time you do the fourth section, you complete the fourth section stabilization, your first section will be ready for the next layer. And in that particular sequence, you will never lose time in waiting time. Then, of course, there will be a reduction of cost of construction because of the reduction in the cost of material, because of the reduction in the cross-section areas as detailed in the previous slides. Now, coming back to the stabilization of BC soils, this I have taken as a case study, because see, you all know that BC soil is present widely in India. And if you see the graph, the gray color is all about the BC soil, which is present in Gujarat, Madhya Pradesh, Maharashtra, parts of Goa, Karnataka, Telangana, and Andhra Pradesh, and some parts of Jharkhand, and not in Orissa, of course. And the beauty is 20% of the total area is being captured by the central and the western parts. The rest is Deccan Plateau and Maharashtra, Madhya Pradesh, and Gujarat. Why they are known as black cotton soil? Because generally you grow cotton exclusively in such type of soils. Now, if you see the typical characters, because that is what is aesthetic part which we talked about, but when it comes to engineering part, the typical characteristics of the black cotton soil is fine textured clay in nature. It has high amount of lime, magnesium, iron, with a low quantity of phosphorus, nitrogen, and organic matters. It is black in color because it is formed from the weathered lava rock. That's why it is burnt out and then stored in such a way that the color becomes black. 40 to 60% of your black cotton soil is having a size of less than 0.001 millimeters. The liquid limit volume change is of the order of 200 to 300%, and the swelling pressure is in the range of is as high as not in the range. In fact, it's as high as 10 to 8 to 10 kgs per centimeter square. This is what we have tested for 70% FSI materials, and then soaked live CBR of black cotton soil. 4 days soaked CBR of these black cotton soils, which is found widely in the range of 2 to 4%. Now, because of its low CBR values, the excessive pavement thickness is required for designing in case you intend to use these BC soils in the flexible pavement road construction. But of course, we have a statement considering whenever you have a BC soil, your OGL needs to be ripped by 2 layers, that is 500 millimeters, and then you can proceed with your fresh materials laying of 2 layers. That means what? You need to remove and replace 2 layers of BC soil if you want to construct a flexible pavement on top of the BC soil. Now, what exactly the challenge is seen in the case of a BC soil is black cotton soil is very hard when dry, but it loses its strength completely in the wet condition. Now, what is happening is if you test the unsoaked CBR of the BC soil, it is in the range of 24%. For a sample which has a uh, free swelling index of 70%, 70 to 75%, that is the sample which is being tested in this particular case. So when the same sample is tested for 4 days soaked CBR in the laboratory conditions, the CBR value is 1.8%. That means the same soil, which is generally having a range of 24% CBR, it drops to 1.8% the moment it gets in contact with water. So this has given me an idea. Now, the major culprit of this soil being categorized as unsuitable soil is not the soil, it is the water. And if you are able to neutralize the action of water on ABC soil, whether it is soaked or unsoaked, your CBR will remain 24%. So this is the idea which has started, and we try to work on, and then we could find some materials which are useful, and that is what is will be discussed during the next outcoming slides. So black cotton soil is highly expansive in nature when it gets in contact with water, and thus making it unsuitable for construction. Because of its high swelling and shrinkage characteristics, the black cotton soil has been a challenge to the highway engineers. Now, you have issues, you have challenges. The challenge is when it is wet, the black cotton soil, you are having problem with the strength part. So when you are talking about there is a lesser strength, now in this particular case, when we talk of strength, it is basically the CBR we are talking about. Now, if it is only strength, you can deal with the strength using the lime and cement stabilization or any other mechanical or chemical stabilizations like fly ash and all. But then in case of the black cotton soil, strength is not the only criteria which is low. It is the nature of the soil which is expansive in nature. Now I need to address this expansiveness also if I want to achieve the uh, results, if I want to achieve the outcome of the soil stabilization as the perfect or the suitable or the approved one. Now, how do we address that? How do we change that expansive nature? The only way to change that expansive nature is you need to coat the particles of the black cotton soils with a chemical which will change the nature of the soil particles, like means from hydrophilic to hydrophobic. So the basically you are supposed to neutralize the effect of water on the soil particles. Now, these are the two materials, two types of chemicals which are being used during these studies. One is terrasil and the second one is Jacobon. Terrasil is basically a xylene material which is working as a waterproofing material, and Jacobon is a polymer which tries to bond the two particles, two soil particles. So when it comes to black cotton soil, we need to work on both strength as well as the expansive nature of the soil. So we have started our studies using a combination of lime and then the chemicals, which is organoxylane-based nano materials for waterproofing and acrylic copolymers for developing the bonding. Now, how does that work? How does that chemical work at all? Normally, you have OH group minus OH groups makes the surface water loving in nature, hydrophilic in nature, or water loving in nature. And what this terrasil does is it creates a bond with the OH group, which is on the surface of the soil particles, and creates a nano xyloxane, alkyl xyloxane bond, the SiO2, which is acting as a water repellent. The size or the layer of this particular uh, particle is 4 to 6 nanometers. Now, the beauty is that if you are able to coat your soil particles, the top of the surface of the soil, when it gets coated with the terrazine materials, it develops a uh, alkyl xyloxane bond. It reacts with the OH group of the particles and makes it SiO2 particle size, and then that is basically acting or trying to do a surfacing layer or protecting your soil particles from the water. This is basically the crux. Now, how do you add it? How do you make sure that your entire soil particles is being treated? How are you going to ensure that even the 50% of the particles is being treated? So what is that? What is that limiting value? How are you going to evaluate what percentage, what minimum percentage is required for a for a chunk of soil to be treated, and ensure that the entire crust remains stable if being stabilized using the lime and the nanoparticles. So this is what is being done during the research. And if you see, this is there are materials like lime, Jacobon, terrasil, and then you have the BC soil. This is of course the oven dried BC soil. That is why the soil looks are different. Now what is required is you get lumps of soil. It needs to be dried, otherwise you will not be able to break it. Now the first portion, the first method, first step, what is required is you need to mallet it, you need to break it down to the small sizes as possible. Now, the idea is we are working on a soil particle with a size limited to 10 millimeters max, not more than 10 millimeters. Now, that has ensured that your particles, if 10 millimeter particles are being coated, so anything below within that 10 millimeters is of course it's not getting coated, and you need to ensure that when it is goes as a lump of particles collected together as a 10 millimeter particles and being laid on the surface, your particle to particle contact is not getting crushed much, and even if it is getting crushed, your surface is not exposed to any sort of leakages. Now, what is being done is once you crush it, you need to add the lime on top of it, depending upon the design calculations, and then you need to add terrasil and Jacob one by one. Sorry. Once you add terrasil and Jicobon, you can check the availability of the water, the moisture level, because that is what is required before casting the proctor molds. And then once it is being casted, it is allowed to dry and cure it for 4 days. Why? Because cement also demands 7 days curing, but in this particular case also because it breaks down and it develops the strength. So what is required is it needs to be dried, it needs to be cured for 4 days, and after 4 days, if you are testing for CBR, then definitely you are going to get a good results. Now what we have done is we have tested for 7 days curing, we have tested for 4 days curing, we have tested for 14 days curing, 28 days curing, and also the 56 days curing. The more you allow it, the more the CBR is. And this is a process which is irreversible in nature. So you need to be careful when adding such chemicals to the materials which needs to be supplied, because if it is a temporary road and you want to revert it back to its original tropical crop seasons, it's not going to work in that way. So this is the limitation of this particular study, so that one needs to have in mind before applying such chemicals for their work. Then you can go for the testing of the CBR for that particular modes. Now the beauty is you can demold and then put a drop of water on top of it. You can see the crystals of water here. This is the black cotton soil which is being created using a proctor mold and then demolded, and on this particular side face, not on the top but on the side face, just to ensure that each throughout the depth it is being properly compacted and properly coated. You can see the drops of the water which is shining like crystals. So this is basically giving you an indication. This is being tested in the year 2019, if you see the timestamp there. So this has created a you can say the eye opener to the others. How do we test it? How do we implement it at site? Because it's very easy to work in the lab conditions, but most of the time we get challenged to do the same work in the field because of lack of either the lack of space or lack of resources or lack of availability of the possibilities or the you can say the opportunities. So since we are from the industry, so we get the opportunities also. Apart from the lab trials, we can do the field trials also, and that's exactly what we have done once we have finished the lab trials. This is a table which shows the test results at different doses of the chemicals. The first two columns, terrasil and Jicobond, if you see, we have tried to do the testing at 0.5, zero point 0.8, and 1 kg per cubic meter for soil to be treated. The top line, which is in white, is basically the untreated soil, wherein you can see that the FSI value is 70% and the CBR is 1.86. The 4 days soaked CBR we're talking about, and all these results are soaked CBR only. And if you see the end results, when you add 1% terrasil and 1% Chicobond with 3% lime, the FSI value reduces from 70 to 15, and the CBR value moves from 1.86 to 18.3. And of course, the OMC also reduces from 13.7 to 9.2. So if you see the correlation between the OMC and the CBR, if the OMC is less, that gives you an indication that this soil will definitely have a CBR higher. If the OMC is more, then there is a chance that you may not get the CBR higher. So these are some of the interesting conclusions which are being drawn in during the research time. So if you see the results, CBR increases by 5 times when 2% lime is used, but it increases by 9 times when you use 3% lime. So it's all depends to what is your requirement, whether you want to increase your CBR 3 times, or you want to increase your 5 times, or increase it to 9 times. Based on what is your requirement, you can always choose what type of chemical dosing is required, what type of cement is required, what percentage of lime is required, and what doses of chemicals are required. Similarly, you can observe that your MDT also has gone up, your FSI is reduced, and your water demand is also reduced from 34% when 2% lime is used, and it is reduced to 25% when 3% lime is used. So if you look at the field trials of soil stabilization, you can see this is the BC soil bed, which was removed and plain passed, made it ready to be used. We just sprinkled the terraceous material on the bottom to ensure that yes, the bottom is completely water cured and even nothing is penetrating from the bottom. Then you put the layer which is already taken out from the same place and spread it across. You can see the color of the soil here, which is an indication that what type of FSI we are having here. So what is required is the spreading of the BC soils, then the spreading of the lime bags in place, and then you can spread the limes manually because it's a small section of 50 to 80 meters, which we are used for trial purpose. And then you repeat with a JC, but ideally it is better if you go for a tractor with a auger and rotavator arrangement, because auger will help you to break the soil and rotavator will help you to mix the soil. It's always better to it's always better to mix the lime first, use the rotavator to mix it properly so that in the process it will break the soil also coated with lime, and once it is coated with lime you can use your chemicals to coat the complete soil. So this is how the rotavators are being used to break the soil, and then you can add the terrasil as well as Jicobond in the water tankers directly, which is supposed to be used for spreading water to up to the required level, that is OMC, and then you can spread it behind that spreader. You can move the rotavator to mix it and then roll it, allow it to dry it for some time, and then you can test it. So if you are like this is a sample wherein 1.5 kgs of material is being used for checking the effectiveness of the soil stabilization. You can see there are cracks available. Of course, there are cracks available because of the uh, black cotton soil. But when you see the material is not, water is not getting inside the soil, the cracks are not getting penetrated because of the water material. So this is the impact or the effect of this material which we have seen during the trial stage. So the idea is this check needs to be performed at regular intervals. Make sure that this will, because without this test, you will not be able to ensure that your CBR is going to be achieved or not going to be achieved, because everybody knows that black cotton soil in the dry condition is having a good CBR value. The purpose of treatment is to make the black cotton soil water repellent in nature, and if this test fails, the entire stabilization process is at toss. So in this particular scenario, what is important is the ripper and the rotavators. One second. Yeah, the ripper and the rotavators. What the ripper does is it plows the field, it does the initial braking, and then you can use the rotavator to pulverize the soil, mix the soil mechanically and chemically. If you see how the rotavator is reacting, or how what is the action of the rotavator stage wise, you can see the particle size here. Now rotavator is moving, and finally you can see what size of particles we have on top of the soils. This is what is desired for the treatment, and this can be achieved to the soil once it is being added with the lime. And once you achieve this soil, you can add your chemical and then roll it and compact it. So the controls required, if you see, initial moisture content of the BC soil needs to be around close to 5%, because what happens is your chemical is being directly mixed into the soil, and if your BC soil is having a higher doses of moisture, then it will get diluted. The chemical will get further diluted, and you will not be able to achieve the required strength. And so, at the same time, what is being tested is if the moisture, initial moisture, is higher, it's always better to add the lime first, add for a day, and then in the next day you can add the chemicals, because lime is acting as a water absorber, and it also allows to dry the material quickly. Then pulverization is the critical area, critical point to be observed as the soil stabilizers. And of course, spreading, absorbing moisture, further breaking of particles, use of rotavators, busy soils, and lime in the field. When you do the test, the hole created by using the sand replacement method test needs to be filled with the suitable same material. Otherwise, it's going to be a critical area for ingress of water. So the idea is you need to make sure that you are not allowing any type of water ingress into the section of the soil, because the moment you are allowing the water into the soil, the shear strength between the particles reduces, and in short, that will have an impact on the reduction in the strength of the particles. So you can always go for a DCPT, dynamic cone penetration test, also in the field, which will have a smaller, like 10, 15 millimeter size of rod, which needs to be penetrated, and it will give you a logical CBR value, which is supposed to be available there. So if you look at the benefits, again, similar to what you have for soil stabilization, it enhances the strength, lowers the permeability, lowers the compressibility, and of course, it develops the water repellence nature of the soil. So it basically eliminates the defects being caused because of the presence of the soil, presence of the water. So you can enhance the quality of the soil layers, controls soil disintegrations. It allows you to quickly dry the soil layers after the downpour and resolve critical subsurface issues. So that is what is the end of my presentation. Now you can have any queries. You can we can interact. I think we are ready for that. Yeah, Dr. Pankaj.
Thank you, sir. Now I request the participants, if you have any doubt.
I hope I have not bored people.
No, sir. So participants are requested to mm, share if they have any doubts with sir. The participants are requested to discuss with our expert if they have any doubt during the presentation.
Either I am crystal clear or I have nothing done.
No, sir.
Anyway, not an issue. But anytime you can reach me out, because my number is there with Dr. Das. So you can be in touch with me anytime, anywhere. Whatever sort of helps we can provide, we will be ready to do that. That is not an issue. So please share my number with all the participants also. I am glad to
Definitely,
help
sir. It will
them
be
whenever
shared.
there is a requirement.
Yes. Any Any doubts from participant side? Any questions from participant side?
No issues.
Yes.
I think people are just brief about full depth reclamation. See, I have not done the full depth reclamation, so it will be difficult for me to talk on that. Nothing.
Yes.
I can see the feedback. Like there's only one question about the full depth reclamation, and I'm sorry to say that I won't be able to speak on that because I don't have a hands-on experience on full depth reclamation.
So no more question. So our co-coordinator, Mrs. Mosumi Mahapatra.
Sir, one question with me.
Yes.
Can I ask?
Yes. 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 Yes,
You should be
definitely.
Sir, good evening.
Good evening. Good evening.
Sir, my question is, in northern hilly areas, can
Okay.
we stabilize soil in the rainy season?
No, not possible.
Not possible.
No. See,
Thank you, sir. Thank
the problem is in the rainy season, if you do such type of work, it will your cost will be higher because your requirement of lime will be higher. So you won't be able to make it cost effective. And it needs a drying time also. And when there is a continuous rain, you will not be able to dry it properly. You may be able to cover it from the top, but from the sides, whatever the runoff water is there, that will be beyond your control. If you are
sir,
able
sir.
to make a proper drainage from the side so that nothing is getting into your stabilized mat, because top you can give a tent and cover it, but what about the bottom? Because in the hilly terrains, one side is valley and the other side is a hill.
Sir.
If you are able to protect your soil, definitely you can do, otherwise you will not be able to do it.
Sir, sir.
Good evening, sir.
Now it is a vital role, a vital issue.
Yeah.
Good
Okay,
evening,
thank you,
sir.
sir.
Yeah, good evening, Saipriya.
Sir, actually, what is the best time for stabilizing the black content soil?
My choice is if it is on the summer.
Yes, yes.
My cycle time will be minimum. My drying time will be high. Instead of
Yes,
waiting
sir.
for 4 days, I can start the next layer on the second day or the third day only.
Yes, sir. Moisture
I
content
need
will be
not,
very less.
yeah, I need not work with I need not be worried about the moisture part.
Yes, yes, sir. Definitely. Summer will be the best.
Summer and winter, but not the rainy season.
Yes, yes. Summer and winter.
Yeah.
Thank you.
Any more question? Any more question from participant side? Or we'll close the program? Is there any question from participant side? Okay, there is no question. So before closing this session, I want to give my heartfelt thanks to our speaker, our resource person, our guest, Dr. P. Gururaju sir. The presentation was very nice, and I think the participants have gained the knowledge from our expert. So, with your kind permission, sir, can we stop this program?
Yeah, definitely. Definitely, not a problem. Thank you very much.
Okay. Okay. Thank you, sir. And good night, sir.
Good night. Good night. Good night, all.
Thank you, sir. Sir, namaskar.
Namaskar. Namaskar.